Hi, in this exercise we want to do another centre of mass example suitable for years 16, 17 and above. And it goes like this. A homogeneous length of wire is bent into a semicircle of radius r as shown. Find x bar, the distance of the centre of mass from the diameter. So if we keep referring to the diagram on the right, from first principles regarding the element of arc length delta s, its moment about the diameter will be x times delta s, which equals x square root delta x squared plus delta y squared, which simplifying becomes x square root 1 plus delta y over delta x all squared times delta x. So using the calculus principles, we have the total moment of the wire will be twice the integral between 0 and r, x square root 1 plus dy dx squared dx. And simplifying that, that will come down to integral between 2, the integral of twice the integral of 0, twice the integral between the limits 0 and r, xr over square root r squared minus x squared dx. In the little block on the right, I've explained how that integrand was simplified. And the factor of 2 comes with the fact that the integral, if it was just a 1, it would just be the upper half of the wire. And we want the bottom half as well, so we need to multiply that integral by 2. So anyway, having got so far, let x equal r sine theta, and then we will find that the total moment is 2, the integral between 0 and pi upon 2, r squared sine theta, r cos theta d theta over r cos theta, which simplifies nicely down to twice the integral between 0 and pi upon 2, r squared sine theta, which is 2r squared cos theta, but with the limits reversed because the integral of sine theta is minus cos theta. So the upper limit is 0, the lower limit is pi upon 2, and substituting those in, that easily comes to 2r squared. So x bar will be 2r squared divided by the mass of the wire, which is pi r, and that comes to 2r over pi, and that completes the exercise. Now, using Pappus's theorem, when we rotate the wire through 2 pi radians, we will generate the surface of the sphere, surface area of the sphere, which in that will be 4 pi r squared. And Pappus's theorem says that that will be equal to the distance travelled by the centre of mass as it goes round once, multiplied by the mass, which is pi r. So 2 pi x bar pi r equals 4 pi r squared, and then x bar will be 4 pi r squared divided by 2 pi squared r, which equals 2r over pi. So I've just made the remark that Pappus's theorem can be worth knowing sometimes. Anyway, that brings us nicely to the end of the exercise. Thank you for listening.